Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Adam bin Zaidi. Today I want to present about the VVT or variable timing for vehicle Volkswagen. Today I want to present point of introduction and history of product. First, introduction. Volkswagen variable valve timing has programming built into the engine control module or ECU. Based on driving condition variable valve timing, optimization automatically and continuously adjusts the valve timing depending suit operating condition, RPM, and can increase fuel efficient on how the vehicle ECU is programmed. And second, history of product variable valve timing Volkswagen. Variable valve timing VVT or variable valve timing was first patented by Fiat in the late 1960s. Alfa Romeo was the first manufacturer to introduce VVT into a production. However, vehicle in the 1980 Spider 2000. Since then, many manufacturers have incorporated the principle of VVT into their design. That's all. Thank you, sir, for listening to the presentation I made earlier. Thank you, sir.
So for theory of operation VVT in Volkswagen, in internal combustion engine, variable valve timing that we call VVT is the process of altering the timing of a valve leaf event and is often used to improve performance, fuel economy, or emissions. The valve within an internal combustion engine are used to control the flow of the intake and exhaust gas into and out of the combustion chamber. The timing, duration, and length of this valve event was a significant impact on engine performance. Without variable valve timing or variable valve lift, the valve timing is the same for all engine speed and conditions. Therefore, compromises are necessary, as engine equipment with a variable valve timing actuation system are free from the constraints, allowing performance to be improved over the engine operation range. Piston engine normally use valves which are driven by camshaft. The cam open the leaf the valve for a certain amount of time during each intake and exhaust cycle. The timing of the valve opening and closing relative to the position of crankshaft is important. The crankshaft is driven by the crankshaft through timing belts, gear, and change. VVT system use all sorts of sensors, but the most important are the camshaft and crankshaft position sensor. The ECU use this sensor to monitor the relationship between piston location and valve position. The crankshaft is connected to the rod and piston, and the camshaft lobes trigger valve lift event. Thus, with the information from the crankshaft and camshaft position sensor, ECU can learn how fast the engine is rotating and the relative position of the piston and the intake and exhaust valve. The variable valve timing system further optimize the timing of opening and closing the valve. In addition, VVT more often improve performance and produce emissions. Besides, VVT also provide best of both worlds. Thus, it provides smooth idling and at low RPM and maximum power high RPM. To adjust the camshaft, the engine control unit activates the solenoid valve. They in turn open oil galleries in the control housing. Engine oil flow through the control housing and camshaft into the fluid variator. So for the inlet camshaft adjustment, the inlet camshaft is regulated by the engine control unit over the entire speed range of the engine. The maximum required is 52. The adjustment depends on the adjustment map stored in the engine control unit. So the design of the fluted variator for the inlet camshaft for Volkswagen is the adjust mechanism consists of housing with outer rotor that directly join to timing chain, or inner rotor that directly join the camshaft. So the variable valve timing technology control three key characteristics of the intake and exhaust valve. So the first is valve timing. The point is the piston movement at which the valve open and close. Second is valve duration, how long the valve stay open for engine. And then valve lift, how much the valve physically open to bring the more of air and fuel. To do this, various sensors such as airflow and camshaft position sensor feed the information to the car ECU, which then use various mechanisms to control the aforementioned valve characteristic. Volkswagen system, for example, physically move the camshaft in order to give the valve more lift.
Hi, I want to tell you about the Volkswagen VVT system. The Volkswagen VVT system use a solenoid to amplify the engine oil pressure to enter the cam pulley and then send to the camshaft. It starts from the oil sump, then pump through the oil pump and send to the solenoid. The solenoid amplifies the engine oil pressure and then enter to the cam pulley and continue to the camshaft. Okay, this is a diagram system for VVT. Okay, this is oil sump and have an engine oil. Okay, engine oil is pumped from oil pump and sent to the solenoid. This is solenoid. Okay, solenoid make the pressure to send to the cam pulley, and cam pulley send to camshaft to make a VVT system. Okay. This is VVT system solenoid type. Here on the top head, this is solenoid. This is housing of solenoid. This is a cam pulley, adjustable cam pulley, and this is a camshaft. Alright, and this is type of side. Okay, the sensor have at the side in the cover of timing belt or timing chain, and in it this is a housing VVT and adjustable cam pulley, and this is a camshaft. Okay, in addition, the ECU also serve to control the VVT aperture according to the set RPM. ECU get signal from RPM, airflow sensor, angle sensor, oil pressure sensor, and animal sensor. And ECU get the signal from the sensor and calculate and send to solenoid to control the VVT opening. Okay, this is a diagram. This is a oil sensor, airflow, map sensor, angle sensor, oil pressure. Okay, the sensor get a signal and send to the ECU. ECU calculate the signal from the sensor and send signal to the solenoid VVT. These two for control the opening of VVT. Okay.
Hello, my name is Muhammad Zulkarnain bin Muksin and my matrix number is B09211000099. Okay, I will continue about the advantage and disadvantage for this VVT. We start from the advantage first. The main advantage of having a VVT technology is it will provide in your engine revolution per minute. When you step on the gas pedal to accelerate the vehicle, your engine will be capable of a higher RPM, which generally giving more power to your vehicle. Next, better fuel economy. Engine efficiency has a lot to do with the timing of a exhaust valve and intake valve. If this valve can be managed and timed properly of the VVT technology, then the engine will be able to produce the same power without needing so much fuel. If your engine doesn't require as much fuel, then you will see your gas mileage increase. And the third one is lower carbon emission. Anytime your engine provides a better fuel economy, you will see reduced carbon emission too. VVT or variable valve timing technology does not get enough credit for this eco-friendly nature. If a higher RPM and better fuel economy weren't enough to convince you that this technology is beneficial, then hopefully it's able to reduce carbon emission will change your mind. Last for the advantage is increase engine lifespan. If you continue to maintain an efficient and high-performing engine, then you can expect to get a great number of years out of it. A lot of people will wait until their engine goes bad before they decide to replace their vehicle. If you have variable valve timing or VVT in your engine, then it will help keep it strong for as long as possible. Of course, there are other factors involved in keeping an engine healthy too. Make sure you regularly get oil change and use the right kind of fuel. Now we're going to disadvantage of VVT. I think we all know that all vehicles that have a VVT will be more expensive and the engine will be more complex compared to a regular vehicle. That's all for me. Next will be continued by Muhammad Nazmi.
In my opinion of technology in the future, every car is created with a system like VVT or DVVT or VTEC, and as well as equipped with a turbo system. This is because the VVT system can provide the rate of combustion in the combustion cylinder to be efficient, as well as the use of the VVT system like in a high RPM or the low RPM. With the addition of the turbo system, vehicle can be created with a small size engine such a 1.3 but have the same power as large engines such a 1.5cc. This is due to a more perfect combustion process, as well as the density of the quantity of gasoline and air in the combustion chamber. So the VVT actuator, or known as a solenoid, need to be repositioned in front of the engine to facilitate the work of changing the solenoid. The VVT system is good, but the position of the component need to be improved. In the original manufacture of the VVT system on this car model is in the timing belt casing or timing chain. It will make it difficult to replace or repair the VVT actuator. So, and the last, the current study introduced the variable valve timing. So being trapezoidal enables the rotary valve a change in the inlet and exhaust timing continuously, therefore allowing it to control the engine load without the need for the throttle valve. The geometry of the valve is studied in detail, calculating the intersection areas between the windows of the valve and those of combustion chamber during the engine cycle. As the valve opening are trapezoidal and the opening of the combustion chamber is trapezoidal as well. There is multitude of geometry variables that need to be optimized during the idle of the engine need to breathe through just a very small area, while during high load operation the opening need to be generous. Finally, the trapezoidal rotary valve system is compared for the conventional VVT system.